Okay, we're going to start. Sorry, you can't see me online. I'm the crowd camera, so you can just see the crowd and not me. Welcome all. Thank you for braving the weather and the COVID and all the other things that are happening. If you're here in person, enjoy double pizza tonight. It's a double pizza special because no one showed up. Um, there was vegan and gluten-free pizza. I just want to point that out. We ordered special, so you know who we're talking to. All right. um, Welcome. This is probably we've been having a little meeting here in Power BI meetup headquarters. We reckon this is probably going to be the last one for the year because I think next month is just going to be a bit too quiet and a bit too late and have our Christmas time and we'll come back. We'll probably come back. I don't think we'll come back in January. We'll probably come back in February. So since it's the last one, I want to say thanks to everybody for joining us for this one and for all the stuff through the year and have a happy holidays and all of that sort of stuff. It's really great to see you all either in person or online. And yeah, it's a privilege to run this community. It's an amazing community. I think we're the biggest Power BI community in Australia. So we've overtaken Queensland and Sydney. So we did that this year. So well done. Um, and that probably makes us one of the biggest Power BI communities in the world, to be honest. If not the biggest. I think maybe Norway has a ridiculously big one because they do like global events. But yeah, we'd be right up there. So very amazing kind of thing. And I know everybody that I've met in the community has always been so generous with their knowledge and the way that they share their experiences with Power BI and the way we use this technology and Fabric and the other sort of related technologies that we use. I just wanted to say thanks for you guys and hope you have a great holidays. It's November. We are here for had a few interesting features come out this month. Um, the new type of button slicer. So we've got a new way of doing so instead of having the old tile slicer, which was the horizontal slicer that you used to set up, it's now got a nice set of buttons. It's much more configurable. It does look a lot nicer. So probably replaces the chiclet slicer. If you're using chiclet slicer, you can use now the default button slicer. So that's a new standard visual, and that's what the second iteration of the new visuals that are coming out in Power BI. So we've had the card, which is looking really good now. I don't know if you've seen the new tile visual, but we've also got now a new version of the slicer. Now the slicer is going to go through 5 changes because there's 5 different aspects of the slicer. There's the buttons, there's the numbers, there's the dates, there's the different the drop down boxes and lists and things like that. So you're going to see changes across all of those in the slicer, but they've only changed one bit, which is the horizontal tile slicer or the button slicer, they call it. Some other things, little bits and pieces. Data sets are now called semantic models. So they've changed the name officially in the web. So if you see semantic model and you're wondering what that means data set. They just have completely changed the name. I like this change because it disambiguates things a little bit for me. Data set means certain things to certain people. I think semantic model also means what it really is in Power BI. They made this change to reflect the additional capability that Power BI datasets have now. So you can do things like calculation groups and all this kind of stuff that's available in semantic model, things like SSAS. And so they are now officially calling them semantic models. So that's kind of cool. And there's a couple of bits and pieces that came out. So some interesting stuff that came out. So check out the November feature summary. There's some really interesting things coming out very soon as well. I expect December to probably have some pretty cool features being announced. Obviously, there's been a lot happening in the AI world and in Fabric and all that kind of stuff. We won't cover that today, but definitely worth checking out what's happening there. Very interesting space. All right, before we get started with the main presentation, I just want to say thanks to our sponsors. These have been our sponsors for I don't know how long, like what, 7, 8 years. We've had the same sponsors, so we thank them for their commitment to our community and that we've got Servian, which is the very nice office we're in, as most of you know and have been here. Servian multi-cloud data, enterprise data solutions. They do a little bit of everything across a little bit of everything in terms of cloud. So if you're in the enterprise data space, then obviously put Servian on your Rolodex. And the other people we want to thank for their sponsorship throughout the year is obviously Sirius Technology. Donna, who's going away on maternity leave, she's here tonight. This will be the last time we see her for a little bit. So good luck, Donna, with all of your stuff. Sirius Technology are obviously recruiters in the BI space. They do data, front end and back end recruitment. So if you're looking for a job or you're looking for a person, then check out Sirius Technology. So thanks to those guys. They supply the pizza, and I don't know. It's just awesome having sponsors to be able to do this kind of stuff. Right. Well, on to the main event. We've got a regular from our community for, I don't know how long. How long has Sam been coming? But Sam Fischer, he's a principal consultant at Revenite. I'm sure he'll give himself a decent introduction, and he'll take over the screen, and then I'll swap it over for those of you that are here. Sam will come out of the speakers. Now, if you've got questions, let me know, and then you'll have to come up here and ask your questions so Sam can hear you. So he can kind of hear me, but he probably won't be able to hear you properly. Sam's an apology today because he was going to be here in person, but he's sick. So thanks for doing this anyway, Sam. I appreciate it. We'll hand it over to you now. So thank you, Sam.
All good. Thanks, Greg. And yeah, apologies again that I couldn't be there in person. But yeah, there's a bit of sickness going around. Don't want to spread around any further. So that's all good. Anyway, so yeah, the topic for today is around how we create a star schema automatically in Power Query, because it's not always super obvious out of the box. I'll take you through a few patterns to do that. So to get started, I'll introduce myself. So again, my name's Sam Fischer. I'm a self-described Power BI guru based out of Melbourne. I've been working with Power BI about as long as I've been coming to the meetup, which has probably been 5 or 6 years, so quite a long time. Again, I'm a principal consultant at Revenite, mainly specializing in Power BI. And within my role, I also manage a business intelligence center of excellence team at one of our clients. So we've got a strong team of developers there as well. Outside of work, I also maintain my blog, apexinsights.net, where I cover a lot of different useful techniques within Power BI. It's been a bit quiet of late, but I'm hoping to put some more content on there coming up soon. And just in case anyone was expecting any different, I have to emphasize, I often get mixed up for a different Sam Fischer out there, very, very similar look, exact same spelling, who's gotten very famous the last few years. Sorry to disappoint, I'm not him. I'm more the one that's focused on Power BI. Cool. So agenda for today. So we're going to start off with a little bit about working with data files as flat files. When might you deal with them? And we're going to compare them to a star schema, and within Power BI, which one's better? What are the trade-offs there? Bit of a spoiler alert, star schemas tend to be the better approach to go with. So that's where we're going to go through a few techniques you can use to convert a flat file into a star schema. So we'll go through doing it manually with something of a staged queries approach within Power Query, but then we'll actually go through a more automated approach using metadata-driven tables to get us that result with a bit less effort. And also go through a few assumptions of what I'm expecting from you guys as an audience. So I'm going to assume that you guys are already familiar with Power BI Desktop and familiar with Power Query. I'll assume that you guys may have heard of star schemas, but look, it's not essential. We'll go through the really important stuff throughout the session. I'll assume you guys can handle a demo heavy session. I don't have too many slides to go through. And I'll also assume you guys will rate this session 10 out of 10. Okay, so flat files, when do we deal with them, and what do we even mean by flat files? So typically when we talk about flat files, the easiest way to think about it is a single file that has all of your data contained within a single table. So you don't have things broken into different tables like a relational model. It's all in a single file there. And the question is, when might you deal with them? Because in reality, it's a little different to what you'd want to get. So what you'd want to get, your expectation is to have all of your data available to you as a Power BI developer from, say, a data warehouse. And that data warehouse would be maintained by data engineers. They're bringing in data from different source systems, integrating it all together and providing you with facts and dimensions, make things quite easy to model and build things out in Power BI. That's the ideal scenario, but the reality is often quite different. You know, you may have data coming at different scales from different providers. So you may have some data coming from internal users within the business where maybe they maintain a manual spreadsheet of information. They want you to build a Power BI report off of that. You may have data coming from external providers where you maybe don't have the luxury of bringing that into your data warehouse. Maybe you've just got third-party SaaS providers where you as an organization are using their platform to manage some of your data. And the only way that you have to get out of that data might be like a web-based querying tool that just generates CSV files for you. So that might be what you're stuck with as well. Or you might even just have APIs to either connect to that data or otherwise, where you'd be pulling out, say, JSON files as more semi-structured data. So you may have any number of different flat files that you may want to integrate together. And without the luxury of having a data engineer to do it, we've still got other tools at our disposal. So this is where we can use Power Query to actually take some of these flat files and build out something that's a bit more consumable within Power BI to make things easy to report off of. Cool. So let's get into the demos. So the first demo I want to take you guys through is to understand a little bit about a flat file and what are the pros and cons of using that in Power BI. So I've loaded up this existing file where if I jump to the model view, which of course, as soon as I'm doing a demo, it's not particularly happy with it. There we go. So here I've got a preloaded Power BI model where I've just got a single table within my model here. And this is what I've called my sales flat table. So if I jump to my table view, I can actually see the data that's represented in this table. So each of the records in this data set describe a line item of a sales transaction. And this sales transaction comes from the Contoso data set, Contoso being a fictional retail organization that operates across the world. So each of these records refers to a line item of a transaction, and we've got a lot of different columns here to describe each of these sales transactions. So we can see an individual key for each of the line items. We can see the date key, which is when the sale was made. We can see a number of different columns that can, in fact, be built out as measures in DAX if we so choose. So unit cost, unit price, discount amount, sales amount. And then we've got a number of different other columns that effectively describe the transaction. So we've got sales amount, channel name, store. So was the sale taking place in a brick and mortar store? If it wasn't, we can also look at, say, if it was an online sale or from a reseller, from the channel name there. We can also see information from the stores about the stores themselves. So what's the employee count in the store or the selling area size? And then we can even see what country and what continent is it based in. But on top of that, we can also see information about the promotion. So if there was a promotion applied to that transaction, any number of these promotions, what was the percentage discount that was applied? What was the start and end date? And then for each of our products, what was the name of the product? What was the description, the manufacturer, product category and subcategory here? And then even some information about the date. So for the date that the transaction took place, what was the name of the month that it took place? What was the day of the week, the year, etc. So as you can see, there's a lot of information here across all these different columns, and we've got about 1.5 million rows worth of sales transactions here. So there's quite a lot of data here. And one of the challenges you'll find is when we want to actually understand a bit about this data set, we've got to look at this view here and kind of figure out what's going on. Even if we're looking at this field list here, it's not super intuitive, right? So you can see that I've got my my promotion start date. It's right next to my quarter of year in the field pane, and that's right next to my region name. So if I want to get some conceptual sense about describing these data, it's a bit tricky with just this flat file structure here as well. So that's one of the things to note with a flat file. But there's a lot that I can still do with this, right? So even with this single file, I can still build out a lot of visuals and do some analysis of what's going on in the data set. So maybe I want to start with a line chart, and I maybe want to see, let's see, sales by date. So I can select on my x-axis, I can find the date key right here. And on the y-axis, I can find my sales amount. And I'm not going to bother doing DAX measures here just because the focus of this session is more on Power Query. So we can see here that I've got my sales over time from the start of January last year. You can see there was a bit of a dip after the Christmas period. It starts to pick up around Feb, March, dips down again in March, and then we've got pretty consistently high sales for across the rest of the year. And of course, it's ramping up as we get into November, December, ramp up to Christmas, and it goes back down again. It's pretty seasonal activity that you do find within retail sales here. And we can pretty easily drag in some fields and do some extra analysis to understand what's happening here. So maybe I want to see what are the promotions that are most effective, right? So I can maybe in my legend, I can bring in, let's bring in my promotion name. This isn't super helpful, but what I can do is if I swap this into a stacked column chart, I can actually see pretty clearly that over time, some of my promotions are more effective at driving sales than others. So this yellow one here, this is actually the times where we have no discount. And this is kind of between the holidays. We don't have too much of a discount. But we can see here that most of our sales in this August-September period is being driven by the North American back to school promotion. And we have got some other sales like the European sales there as well. But we can see even at Christmas, our sales are dominated in the North American market and with a little bit from Europe and from Asia as well with their holiday promotions as well. So we can do some analysis here. We could even perhaps drill this down into looking at individual stores. So what I might do is I'll get rid of this legend so we can look at this a bit more easily. And then we'll go back to our line chart. And let's say that we want to cut this by store. So we want to see what our sales look like by an individual store. So I'm just going to bring in a slicer here, just resize it a little bit. And for the field name here, I can bring in store name. So here, these are all my stores that Contoso operates out of. I can see what the sales look like for Albany, Alexandria, Amsterdam, all these different stores here. And then maybe I want to cut this by product as well. So I can bring in another slicer and I can make this slicer refer to product name here. So here's all my list of products here. So I can look at this for the digital cameras that are each of these M300 models, all the different colors. I can look at the M200s and I can see all the different colors here and the different sales going on here. So one thing you might have noticed when I just selected this silver camera here is this actually updated my store name here. So if I unselect it, you can see that I've got this Albany store, but I don't have that when I have my silver store my silver product selected. And the same goes when I select Albany, that silver camera actually disappears. Now, how you can interpret that is that there's actually no sales that take place in this data set for that particular silver camera at the Albany store. And if you're used to Power BI, you may be able to intuit that and figure that out. But this is often a common challenge for people as consumers of Power BI where you can add in these different slicer values here, but it's not always clear what's going on when sometimes elements from the slices go missing. And as a developer, you sometimes have to explain to your end users what's going on there. So it can be a bit of a challenge to get at. So there are ways to deal with this, right? So within the tool, you can edit interactions to make it so that your slices don't talk to one another, so that it always shows the full set of products and always the full set of stores. You can apply measure-based filters as well, but at the end of the day, there's more scalable ways to deal with this. And this is where we get into structuring things quite a little differently as a star schema. So this is where I can jump into my second demo file here, where I've got the exact same data loaded, but in a slightly different format. So if I go to the model view, this is what these loaded data look like in this new star schema format. So you can see that there's multiple tables this time in the model, where I've got this table called fact sales in the middle as a fact table, and I've got these different dimension tables around the outside. So when I refer to a fact and dimension table, a fact table effectively refers to any business activity or event that happens. And each of these dimension tables, they refer to like descriptions of the fact. So kind of like your who, what, why, when, and where. So for example, a sale has a product, which is a what. It has a date that happens in the calendar, which is the when. It has a where, which is the store dimension. It has a how, which is the promotion dimension. You can think of it as the maybe not the how, but the why. And then the channel is more of the how as well. Sorry, my Google Home speaker's just going off in the background. Anyway, so each of these tables come together to form a star schema. The reason why it's called a star schema is because each of the dimensions relates to the fact in a one-to-many fashion. And in the old kind of crow's feet notation, the fact table kind of looks like a star there. So looking at the actual data that's sitting within this model, my fact sales table, this has all my sales transactions here. It's got that same 1.5 million sales records here, but it doesn't have all the columns that I had in the flat table. So we've still got the sales key, we've got the date key, but we've also got these additional IDs here. These are foreign keys that will relate to my other dimension tables. And then the rest of my columns are just my measure-based columns that are going to be used to do my analysis on. So my unit cost, my sales amount, etc. And then for all my other entities within here, like my calendar, my store, these are all wrapped up into separate tables. So this already addresses one of the interpretation challenges with the flat table, which is where if I want to refer to fields that are talking about channel or product, instead of having to sift through the entire table, I can just go into these more granular product tables. So I can see my brand name, my class name, my manufacturer for all the products here. And this has all my distinct products within this table. Same goes for my calendar. This will have all of my distinct dates going back to the 1st of January last year, all of my dates for my sales transactions here. So in the reporting view, I can build out the same kind of analysis that I could do in the flat table, but there's slight differences in what I can do. So I can build out those same visuals fairly easily. I can bring in a line chart, and then I want to build out my same visuals. I can add my date key into the x-axis. It's already a little easier to find things because I just go into the appropriate tables that I'm referring to. On the y-axis, I can just go into fact sales, and then I can find my sales amount. I've got the same visuals before. I can also bring in my two slices just as we had before. So I can bring in my store slicer. That's going to come from my store dimension, just under store name. And then I can bring in my product slicer as well, based on my product name. There we are, product name. So if we do that same slicing and dicing as we did before, if I say select my Albany store, out of the box, I've still got my silver camera here. It's not disappearing. It's not going anywhere. That makes things a bit easier to interpret. If I actually select Albany and I select my silver camera here, I have the option to do that, but then it's going to result in my visuals here being blank. And sometimes that can take a little bit of user training, but it tends to be a bit more intuitive than if the slicer elements just disappear. And the reason why these slices don't talk to each other anymore is actually down to the structure of the model here. So back in the model view, when I'm slicing on my store dimension, what I'm actually doing is I'm applying a slice on the store dimension, and that's passing down into the fact sales table via this relationship. And this relationship has the filtering directions, this little arrow that says that filters will go from the store dimension to the sales fact table, but they won't go back up. So similarly, if I'm filtering my sales fact based on a store dimension, I'm not passing that filter back up to my product dimension that has my list of products that are in that slicer there. So that's why these guys don't interact, and that makes things a bit more intuitive. And if you want, you can make them interact. I probably wouldn't do it by turning that into a bidirectional relationship because that causes other issues. You can do that with other filters that you can apply in the model as well. But the take-home message here is that you can make things a bit easier and more intuitive for end users if you structure things in this start schema way. The slices act a bit more intuitively. Your fields in the actual model are a bit easier to find. But there's also one other advantage, right? And this is down to the compression of the model in the star schema approach. So to actually look at that, I'll jump back to my flat file table here. And if I go into external tools, I can use DAX Studio to actually tell me how much size this data set and this model is actually taking up. So I can do that by going to Advanced and then under View Metrics. This will run the Vertipack Analyzer tool. It gives me a lot of different information about my model and in parsing it against best practices and what's the cardinality of different fields and all that. But the key thing that I'm most interested in is this total size and memory. So for the flat file, this takes up 36, 37 megabytes within memory to actually use that model. And if I compare that to my star schema model, I can do the same thing. I can go to external tools, run DAX Studio. And I can do that same check where I can look at the advanced tab under view metrics. And then for this model, under summary, I can see it's only taking up 20, 26, 27 megabytes. So I've actually saved 10 meg, which is 20, 30% of the whole model size. It's not super significant for this size of model, but you can really imagine that for larger models that are 10 times the size or more, then that extra 20 or 30% can make a big difference. And I've got the exact same data in both models, right? Like I drew out the exact same visuals in both, but it compresses a lot better when you've got in a star schema model. So that's another key advantage as well. So great. So if we know that star schema is the way to go, how do you get from one to the other? Say your end users only provide you with a flat file and you want to get to a star schema. So that's where I'll take you through some of these techniques now of how you can do that. So we'll jump to our next demo file where I've got the same flat table that we started with loaded into the model and also loaded into Power Query. And you can see these same columns: sales key, date key, unit cost. For the sake of going through this exercise, I'll also filter this just to the top 1,000 rows so things work a bit snappier for the demo. But in order to build out my star schema, I've got to pretty much build out my facts and my dimensions one by one. So the way that I can do that, starting with this flat table, I've got it sitting in my source queries, and I'm going to start by building out one of my staging queries, which is going to lead me onto my first dimension. So what I'll do is I'll reference this sales flat table, and that's going to allow the transformations to be applied. Anything that applies from the sales fact table will flow down into the second one. And I'm going to call this particular query, I'm going to call it dim calendar staging, like this. So what I can do now is I can start by building out my calendar dimension, and it'll become apparent soon why I've got that as a separate staging query. So the first thing that I'm going to do is I'm going to select all the columns that conceptually relate to my calendar table. So in that case, this is my date key, and there's also a number of columns at the end here. So my month name, day, week name, year, and these other ones. I'm just holding down Control on my keyboard while I select them. And while I've got all those columns selected, I'm going to go up to Transform, and I'm going to select Group By. So this is going to give me all the unique date elements within the model. But then what I'm going to do is I'm going to add on an all rows aggregated column onto my result. All rows. Great. So I've grouped all this up. So each of these records here represents a unique date in my model. So I can sort this and I can see that starting from the 1st of April, it's probably not starting from January because I truncated it to the first 1,000 records, but from the 1st of April, 2nd and 3rd, I've got one record per date. And then in this all rows table, I can select this and see in the preview pane, this cell here contains a rolled up table of all my sales transactions from the 1st of April, same for the 2nd, for the 3rd. Great. So this is my first staging query. So in order to actually build out my calendar dimension to be ready to be loaded, I'm almost there, right? I've already got one row for each date, which is unique. So all I need to do is I'm going to reference this guy again, and I'm going to pop this query into my loading queries, and I can just rename it as dim calendar. And all I need to do is get rid of this all rows column here. So I can just go remove columns, and he's gone. So I've built out my calendar dimension. That's ready to be loaded into my model. But I need to get going to build out my other dimensions. So what I'm going to do now is I'm going to reference this staging query a second time. And this new staging query, I'm going to retitle this to be my staging table for dim product. So I can start out by building my product dimension. So for my product dimension, what I need to do first of all is I need to get rid of all these columns that relate to my calendar table because I don't need those anymore. I've already shed those off into my calendar dimension. I can just remove those columns, but I'm going to keep my date key because that's going to be used as a foreign key in the eventual fact table that I use. So now I can expand all the columns. I don't need date key because he's already sitting there. I don't need any of my other columns because they've been shed off into my calendar dimension. And this has my same fact table back to the fact table grain, but I've now got only 32 columns, whereas when I started, I had 38. So I've shed off some of those columns into my calendar dimension. So now I can go through that exact same exercise to build out my product dimension. So I'm going to find all the columns that relate to my product, which is going to be product name all the way through to the end here at product category. I'm going to select all those, and I can group these again. So I'm going to group this by product name, description, and I'm going to do that all rows aggregation one more time. Click OK. And now I've got one row per product here. So at this stage, for my calendar table, this is where I forked off into my dimension table and my next staging table. But there's one extra step that I need to do in this case. And that's because I need to make sure that I have a common, consistent key between this dimension I'm going to create and the fact table. Now, I could assume that the product name is going to be unique, but it might not be a safe assumption. So what I can do instead is I can create my own custom key. So I'm going to go into add column at the top here, and I'm going to go index. I'll create an index column, and this is going to be creating my new product ID. So I'm going to call this product ID. And now this is going to be unique for all my products in the model. Great. So now I can do as I did before. I can reference this to build out my calendar dimension, sorry, my product dimension this time. And all I need to do is remove this all rows here. So we've removed him, and this is our product dimension. Great. So what we would naturally do at this point is we'd reference this guy and we build out our third dimension. We need to re-expand and make sure that we keep this product ID field here. And in fact, I'll briefly show you, all I need to do at this point is to remove these columns, then re-expand by getting rid of these columns from the products. But I'm also keeping this product ID that I've just generated, because when this gets loaded into the model, that's what I can use as the key between the product dimension and the sales fact table. So instead of going through this for all 5 dimensions, I'm going to actually just show you something that I put together earlier. So this actually has all our staging queries already built in here. So we've got our calendar and our product that we've just gone through, but I've done the same exercise for our promotion dimension. I've built out the promotion dimension there. Same for store and for channel. And then once we've done this for all of our dimensions and we've built out all the keys that we're going to need, the last little step that we have to do is to get our fact table ready to go. So we're going to start with our last dimension that we had there. We're going to remove the column that belongs in the dimension there, keeping the key, and then we're going to re-expand this. We don't need to include the channel name column that was in there previously, but when we expand it, this is going to have our fact table down to that same grain. So we're going to have sales key, date key, all these different measure columns, but then we'll have our ID columns in here as well. And then to load this in, I just reference this guy, and then this gets loaded into our loading queries table here. Great. So this is a fairly extendable technique that you can use to build out, to build things out. And I'll also show you, just to make things a bit clearer, a bit of a summary diagram of that. If I just share my PowerPoint again. So how this stage queries approach works is you've got these 3 different layers, source, staging, and loading. They roughly map onto your kind of medallion architecture if you're in a more lake housing scenario. And we start with just our flat table in the source queries. We generate a staging table, which is where we compress and we will group down our fact table or our flat table down into all the unique elements for that first dimension. And then we do 2 things. We fork this off into a loading query where we load off that first dimension and we omit that all rows column. And then we also go into our next dimension table where we remove the columns that we've shed off into the dimension, the first dimension. We re-expand that back into our full fact table grain. Then we regroup that down to our second dimension. And then if we need to, we also add in a new key for that dimension if it's needed, like we'd need to for the product ID. Then we go and fork off dimension number 2. We can do the same for any number of different dimensions that we want. And then finally, we bring it back to getting rid of our final columns for our final dimension. We re-expand that back to the fact staging grain, sorry, the fact table grain, and then we load that into our model there. So that's how this approach works, this kind of accordion approach of compressing and re-expanding as you go. So this approach is quite useful. It's fairly scalable, except for the fact that you are going to have challenges with manually doing this every single time. Say you want to apply this technique across multiple different tables. You may need to naturally if you're integrating different tables, but there is a bit of manual work to do all this. So I found after using this a few times, I tried to think about, okay, is there a more efficient way to do this? So this is where I'll go through our final demo for tonight, which is where I'll take you through a more automated way to do this. So in the final demo file here, I've got my same flat table loaded. If I jump to Power Query, this new approach is going to allow me to do this very simply just by running a simple function. So I've got my same flat table where I've filtered to the first 1,000 rows, just like in the last demo, but I've also got a second table that I'm going to feed in. So I've got this model schema table, and this is like a metadata table that tells me for each of the columns in that flat table. So you can see my sales key, date key, unit cost, all the others in there. In this metadata table, I'm specifying what is the table in the star schema that I want it to appear in. So I want sales key to be in this sales table, and that's a fact table. I want channel name to be in the channel dimension, promotion name to be in the promotion dimension, etc. And I've got one final column here, which is the existing primary key flag. So this is how I'm going to differentiate for each of my dimensions whether or not I need to create that custom primary key that I created for all the dimensions except for the calendar dimension. So that's why I've marked the date key as true for an existing primary key flag. So with this flat table and this metadata table, this is all I need to do the exact same thing that I just did now. And I'm going to use this function that's already been built. So what I can do is I can say for my flat table source, I'm going to select my flat table. For my star schema metadata, I'm going to select my model schema. And all I need to do is click invoke. And when I invoke that, which I'm going to pop in my output group here, I can see there's one record for each of my entities within my star schema. I've got sales fact, calendar dimension, and under this all rows, I can select this. And in the preview window, I can see this has done all that manual work that I had to go through in the last 20 or so minutes. It's done this for me straight away. So I've got my sales key, all my measure columns, so my unit cost, my sales amount, and then all my keys here, my date key and my generated keys for promotion, product, store, and channel. And then under the rest of these, I can see, say under my store, I can see all my stores for my store dimension. I can see under products, I can see all the products. And now, when I want to get these to load these into the model, I will admit there's a little bit of manual work, but all it involves is right-clicking and going add new query. So I can go add new query to generate the sales fact. I can do the same for my calendar dimension, add new query there as well. And I just see that there's a question in the chat as well. Is it always better to reference the flat file than duplicate to create the dim tables? That's probably going back to the last demo, but I would say probably yes, because that means that you're at less of a risk of missing out on extra transformations that you're doing if you need to rejig things. So anyway, so we've got this function. It generates all of our entities within our model with very little effort from us. Has this function actually work? So I'll take you guys through this. This is probably more tailored to your more advanced end users. So if you're not quite following along with this, don't feel so bad, because the function I'll have available to everyone after this anyway to play with and get familiar with it yourselves. But how it works, there's a number of different nested functions within here that does all the work here. In these explainer functions is where I'll walk you through how it works. So for each of the dimensions, we need to go through the same logic that I've got in this query, where let's say if we start with, let's say our calendar table like we did in the previous demo. So we want to start by knowing what dimension we're talking about, and then we need to filter that down, filter around our model schema table down to just referring to the calendar dimension here. From that, we're going to extract out the list of our column names that relate to our calendar dimension. And then we've got to go through a few checks, one of which is to see if for this dimension, if there's any existing primary keys that we can use. So for the calendar dimension, because we flagged the date key as an existing primary key, we can use that. We're going to identify that as the column we use. And then we need to go through this data quality check just to make sure this is going to be appropriate to use. So all we're doing here is that we're just checking that for the calendar dimension at this step here, that we've only flagged a single one of these records as being an existing primary key, because you can't really have two primary keys. That kind of defeats the purpose. So this is a data quality check just to check for that. And we passed that check because there's only the one. Then we're going to go through that same kind of accordion approach, where we're going to group all the records down for this dimension. So using the dimension column names that we got earlier on as a list, we're going to group that up, and we're going to add a column for all rows, which is going to contain every column within the flat table except for those dimension column names there. So we don't need those because we're going to shed those off into the dimension. Then we're going to check, we're going to do another data quality check, which is to make sure that we've already told the model that date key should be a primary key according to the metadata, but does that actually ring true once we've grouped up all the attributes there? So this uniqueness of existing key does that check. It just checks that the row count on the group by step in the previous one matches when we just select all the distinct elements of the key. So that's what this check does. Then from there, if we need to add that extra surrogate key for the primary key, we can do that if we need. We don't need to do that in this step because we've already got an existing primary key there. And then we're going to re-expand it back to our flat table. So we need to start out by grabbing all of the list of columns that we need to keep that don't belong to that dimension. That's what we've done here, removing matching items. We're going to re-expand that back to our fact table grain. And one of the tricky things we do need to address, though, is that by doing that grouping and re-expand in this case, we've accidentally stripped off the data types for those columns that weren't part of the group by. So you can see sales key, unit costs, all those don't have a data type that have been applied there. So instead of manually applying that, the final step that we're going to go through is to get the original column types. So I'm applying the table.schema operation against the original flat table, and that's going to tell me the data types that were initially there. So then what I'm going to do is I'm going to do some magic with some lists here, where I'm going to reapply those missing data types. So you can see here, if I go between my re-expanded where the data types aren't there, they've now been restored in this final step here where I'm reapplying the column types. So that's how this works for one dimension. We can look through this very briefly for a second one, like our product dimension. And in fact, before I do, I see there's another question in the chat. So question from Shelley, is there a risk that the calendar will be missing dates if there are days with no sales? It's a very good observation, Shelley, and you're absolutely right. So this technique's useful for when you've got things in the dimension where you've got sales for. So if you've got a business that doesn't operate on weekends, you're not necessarily going to capture those weekend dates because there's no sales ascribed to those. So this is admittedly one of the limitations of this technique, and this is where just throwing this out, just throwing this function at your data without knowing the ins and outs of like that calendar question there, it can cause you trouble if you're trying to do time intelligence there. So calendar dimensions, it's not the best approach for, but as long as you're happy with just capturing all the other dimensions with what's in the flat table, then you're covered. But it's a good question there because it's one thing to be careful of. So if we did this again for our product dimension, it's pretty much the same as before. We're going to grab our product fields here. We're going to grab those as a list. Then we're going to go through the same checks where if there's an existing primary key, we're going to identify it, but there's no existing primary key. So we don't even need to do this check here, or at least it's passed arbitrarily. And then we're going to group by just like before. In this case, we can skip this check where we're seeing if the existing primary key is unique, because we don't have an existing primary key for product. We need to generate that. And that's what this final step does. So this final step in this group here just checks if there's an existing primary key. And because we know there isn't, it's going to add an index column where it's going to append the dimension name and ID to build out our product ID column here. So this is similar to what we did in the manual approach. And then we'll go through the exact same logic as before. So to actually apply this in the function, all that logic that we just went through is captured in this stuff here. But to actually apply it to each of the dimensions, we've got this recursive function that we need to apply. So starting from our fact table, our flat table, we need to effectively generate the keys for all of our dimensions that we're going to use. So that's what this looping function does, where we start by feeding in our flat table and our star schema metadata, this model schema table here. We're going to feed in the dimension name and how many times we want to loop over that. And we're going to apply that logic that we just went through for the first dimension. We're going to go through and check if we're at the final iteration. If we are, then great, we can stop there. But if not, we're going to recursively apply this function again. And that's how we go through and generate each of our dimensions there. So to go through the high level of how this gets applied, this has the whole logic wrapped up into it, where we feed in our flat table, we feed in our model schema, we start by grouping our model schema table into all those entities there, and then we're wrapping up also our columns that relate to each of those dimensions because they get fed in as well. We generate our dimension lists because that's what we're going to iterate over, and that just comes from the dimensions within this. So it's just these 5 guys here. We're going to define this function that we just went through the logic of, and we're going to apply that logic where we're going to add in those keys. So when we run that internal function, the one that we just went through with this logic here, what that does is it feeds in our flat table and our schema, feeds in the dimension list we just generated, iterates over all the dimensions that are there with this list.count there. And then what that does, that returns that same flat table that we had, same grain, but we've added on all the keys that we need to add on there as well. Now, the final thing we need to do is we just need to work out what are all of the actual keys that we're going to make sure that we need to include within the fact table, so that we have those both in the fact and the dimension so we can relate on them. And then we can generate our full schema here. So going back to our schema grouped into entities step, what we're doing is we're just adding on a custom column here. And that custom column runs different logic depending on whether you're talking about a fact or a dimension. So if you're talking about a dimension, how this works is this tries to add in, it starts with the flat table with everything in it, with all the new keys. We're just going to select the columns that relate to the actual dimension itself. So all the ones that are contained within the column details there. And then we're also going to add in the ID if it exists. And if it doesn't exist, we're just going to do this other step where we just ignore it. So that's going to apply more for the calendar dimension. And then from there, we need to take the distinct elements to group onto just the unique records for each of the dimensions, each of the dimensional values there. And that's for the dimension. For the fact, it's a little simpler. All we need to do is we just need to start with our flat table with all the keys, and we're just going to include the facts columns here. So the sales, unit cost, unit price down to sales amount. And then we're also going to include the dimension keys that we want to include in the fact table so that we can use those for our foreign keys that we can build out our model with. And then we've got some error checking as well to make sure this is covered as well. So at this point, this has us all covered. So this generates our fact table, this generates our calendar dimension, this generates all of our other dimensions, and we can just load this into the model just by right-clicking and going adding this new query. So this is a much faster technique than that manual stage query approach. It follows very similar logic as we just went through. As Shelly mentioned as a question in the chat, it does contain that risk of making things too simple. If you don't know some of the ins and outs, like calendar tables, you want contiguous dates there. It won't have you covered there, admittedly, but this does give you a fairly easy starting point for things. So I suppose to sum up what we've covered, we've gone through flat tables, we've seen where they're useful, we've gone through star schemas and compared the two, and we've seen that star schemas pretty usually the way to go. So I've gone through a few techniques of how you can get from one to the other. So we first of all went through manually how you can generate your star schema from a flat table using that stage queries approach, where we've got the staging and the loading queries, and we're doing that accordion approach of grouping and re-expanding. And then we found that, look, you can take that approach, but it is a bit manual. This is a bit of a faster way using this function here, where all you need to supply is this metadata table. Once you've got that metadata defined, feed that into your function, and that does all the work for you. So if you do want to explore any of this for yourself, I have got all this information available up on my GitHub. So I'll just paste the link in the chat now for all you guys. So after this, if any of you guys want to have a bit of a play with that to learn hands-on for yourself, please feel free to. But other than that, that has the content of the talk just about covered. So I might hand over back to Greg for questions.
Well, that went from like 0 to 100.
Yeah. That's the tricky thing. It covers kind of beginner, intermediate, and advanced, but it does kind of ramp up a bit, I'll admit.
Look, I know Sam. I've known Sam for a while, and I know he's a very clever boy. But yeah, that was unbelievable. That was really cool. All right, does anyone in the room have a question for Sam? Yes, Max. Yeah, I'll ask it on your behalf. I think that's right. So the question is, if I've got a fact table with products with no sales in them, that won't appear in the dimension. Is that correct? Is it similar to the calendar?
That's a good question. So is that like your fact list facts? Like you've got oh no, so you're talking about more if you've got a product that is stocked by a business but doesn't get sold, then yeah, it won't appear in the product dimension there. This is only going to have you covered for where products are actually sold.
Yeah, I think you covered it. Yeah, you could do some appending where we're speculating how it resolve that.
Yeah, exactly.
So that's true of any dimension, is that right?
Well, it depends on how you build it, right? So I mean, if the only reference point you've got is this flat table, then that's kind of all you've got to build it out. In practice, you may have the business providing extra records in your dimensions, whether that be, products that haven't been sold or haven't been sold yet, like say their new product lines are coming up, they may want that already loaded into if you're talking about a data warehouse, you'd want that loaded in ahead of time before the sale, so you got the integrity there. But you may even have like dummy records. So they may have you covered for where there haven't been sales made. Like there are other instances where you might do it. Again, this isn't necessarily going to have you covered for every single scenario, but if you've got a flat table that has all of the transactions that you care about, and you don't have a separately maintained dimension that might be more complete, then this should have you covered for those ones, except for the calendar dimension, which we talked about.
So I've got a question. With the calendar dimension, have you played around with generating a list of contiguous dates between the min and the max and then appending the rest of the calendar to that?
Yeah, I've played around with it a bit. It's still kind of in development for this guy, more because having separate logic to apply for the calendar dimension takes a bit of work that I haven't really worked all the way through yet. Yeah, because getting to the recursive function already takes quite a bit of time to get to that point, but it's definitely a good feature addition to have. I would say for people using this otherwise, I would probably say for the time being, just generate a separate calendar table yourself.
Yeah. So is the ambition for this to be like generate like a drop your flat file here and we'll insta generate a star schema for noobs? Is that?
Well, that's kind of the intention of it, but it's not necessarily. It's not something that I'm going to take as a product to market or anything. It's more a nifty thing that I kind of had an idea of, put together. I thought I'd share it with everyone, partly because it might be useful for you guys to play with, but also it's a good little exercise in what kind of things you can do with Power Query, whether you use this or otherwise. It's a good little example of what's possible there.
Yeah, I think you cover pretty much the full gamut of Power Query functionality there. If you've got recursive functions and functions within functions and expanding tables, and yeah, that's very cool.
Yeah, that's it. It's the kind of stuff that I like to do in Power Query, but there's not always a lot of content out there at this kind of level, so it's good to put out there what you want to see in the world.
Yeah, awesome. Question.
I never use that group by all rows. So I wonder, so under the hood, you always carry the whole data from one reference to the next. Is that very expensive if you deal with a large data set?
Yeah, so it's a good question. So if you're grouping and re-expanding every time, is that expensive operation? And the answer is yes, really, right? So it's expensive, especially when you're dealing with higher scale of things. And this is why once you're dealing with, if you've got a table that genuinely is like millions of records, you probably want to be doing that. You probably want to be doing that upstream in a source system, or say in Fabric in like a lakehouse or a warehouse entity, and keeping it there. This is probably more catered for your smaller use cases where Power Query has you covered from a data integration and data transformation side of things. If you're dealing with a higher scale, this probably won't have you covered. It isn't necessarily the most scalable. This is more catered for those smaller use cases there.
Thank you.
Yeah, this is a true Power BI solution. No Fabric required.
Yeah.
Just Power BI.
Yeah.
This on a nightly basis, so you keep all your tables up to date with the primary keys linking to each other. Wouldn't be too bad, but would you recommend it for any more than daily updates?
So for daily updates,
So let's say you had something you wanted to refresh every half hour. Would it perform fast enough to do it if you had, 10,000, 20,000 records?
it's a good question. I know for these 1,000 records, well, in fact, what I can do, let me go to this. Where are we? If I go to the one that is completed, so if I refresh this one that does the manual approach, that loaded pretty quick just doing the manual approach. So we know that for the accordion manual approach, it's kind of covered. For the metadata-driven approach, if I actually, where are we? If I disable the load on that, and then we will also bring in our store dimension, promotion.
It's pretty cool.
And then product.
Do that feature as new table. That's awesome.
There we go. It's already loaded.
Okay.
Yeah.
How many rows in that data set did you say?
This one was only 1,000.
Ah, okay.
Yeah. But that was more for the demo's sake. Like I would say, it really depends on the size of your data, both in terms of columns and in terms of rows, as to how this is going to perform when you actually load it in practice. But again, for small data sets, you could run it on a half-hourly basis. If you're getting additional rows coming in, every time you refresh this, you're going to be regenerating your primary keys. So you're always going to have that referential integrity. It may mean that if things come in a different sort order, the keys, the actual IDs ascribed to different products and stores may change between refreshes. But if you're getting into the weeds where that's a concern for you, that's probably more where you want to start talking to the data engineering team in the organization.
Yeah, that's where I love what you've presented here, because it shows that cascading approach. And I'd always, whenever I've had a situation like this before, I haven't bothered replacing kind of concatenated keys with surrogate keys to link things, just because how do I do it and keep it in alignment, and as it refreshes, keep it in alignment? I just didn't have a logic to follow to do it, and I was wondering why you were cascading things along the way, and now I see why, and it's actually quite elegant.
Thank you.
And then to see the automated approach, it's magnificent. I love it. Really
no,
good.
thank you. Yeah, like I'd found that staging queries approach, it took me a while over doing these kinds of projects to kind of infer that, to solve that very problem that you found around making sure you got the keys consistent. So this is kind of this automated approach is more of an evolution on that.
So I see that that's a really interesting thing that Richard's kind of pointing out there, is that the logic behind that and the methodology is you potentially can move this into a larger data processing thing like Spark, right? And if you're able to do that, then you've got a situation where you can kind of dump fact tables in, and it's going to generate the appropriate tables out the other end. I think it's worth exploring for sure, because
yeah.
I think there are practices that are out there. So
yeah,
you could rework it. The way they do it is probably relatively similar. It's just
generates the thing.
Yep.
There's a couple of comments. Good for starting point for people who feel a bit overwhelmed with data modeling. Well, I think that's the holy grail, isn't it? To try and give people a way that starts with bad data and ends up with a nice, beautiful star schema. And this is just a step in the right direction for that. I think it's really cool.
So the only thing you're missing here from turning it into a plan you could sell, as Greg was talking about, is that AI model over the top of determining what are my dimensions and what are the fields that should go into those tables, and what is my fact table and what are the fields there.
Yeah.
And if you use the AI model over the top of that, you could tie those two things together and sell it as a product.
Yeah. Patent pending.
Yeah.
It would sell.
That's it.
Yeah, I know.
Yeah.
It's cool.
Yeah, like there's definitely ways you could do that. I think the challenge probably comes down to the data modeling element of knowing contextually what fields belong where. So, for example, like if you've got a geography field, like geography type, continent name, region name, in this case, they describe the store. But if you're just given a flat file and you don't have any context around it, then you might say, oh, does that belong to the store? Does that belong to the customer? And the AI model may stuff that up if they don't have the context of it.
And that's where giving it a run through and showing kind of what the AI models come up with at least gives them a starting point.
Especially if they can tweak it that's right.
This is what we think your facts and dimensions are.
Yeah. Oh no, this column belongs here or whatever. Yeah.
To like validate the AI model. Yeah. I can see there's also some questions in the chat. Let me just have a look. So Jude is asking, the data in the Excel files sometimes starts from a different row, like say 5 rows down. How would this impact the method? Good question. In practice, what I would be doing is, say if you did receive that as your actual flat table not starting until like the 5th row, you probably want to do some transformations just at the start here to remove those top rows and perhaps do like a promote headers row, promote headers into the columns transform to make sure that it appears in this format. So once it's in this format, then you're good to go. But yeah, you may have to do some pre-cleansing, like getting rid of header rows to get to this point first. I think that was all the questions. Some other good comments there. So definitely a good starting point as people are getting up to speed with things.
One more from Dan.
Other ideas what else you could put into the model schema? Because I was just wondering how you could add, for example, renaming of columns, maybe creating a summary table that gives you the number of distinct values for each of your dynamically created tables. Do you have ideas of how to extend that further? Yeah,
it's a good question, because you're kind of barking up the tree that I've already considered as a future state around doing like additional data quality checks. So you might even say for this column, not only are you identifying whether it's got existing primary key, whether it refers to that or not, or you might say whether or not you would expect nulls in the column. You might specify like a min and max range you might do, and you could, through this, also apply a number of different data quality checks, so that, because oftentimes flat tables, when you get them, the data can be somewhat dirty. It's usually better from like a data ops perspective to find those problems immediately and deal with them immediately. So if you can do those data quality checks as you go and say this refresh actually won't work if you're getting that dirty data because you're failing it due to those data quality checks, then you can implement that here as well in your model schema, where you can define those data quality expectations, or your kind of data contracts, if you will. Definitely an idea that I've toyed with.
All right. Well, I think we'll call it there. Sam, check out Sam's blog if you haven't. Sam's got some great content. As he can demonstrate, he thinks a lot about Power BI, and he's an advanced user, particularly in the Power Query space. So great effort. Thanks, Sam. There's the blog. I'm sure he'll put some things in the chat for all the things. There's the blog. Yeah, thanks, Shelley. Good work. For those of you that are here, if you want to get your hands on the GitHub repo, then you can always hit up Sam on LinkedIn. Otherwise, hit me up or put a message in Meetup, and I'll give you a link to that GitHub repo because I'll have it in the chat from the meeting. So definitely worth something to hold on to. And if that went completely over your head because you're only starting out with Power BI, do some stuff in Power BI and then come back in like 2 years and you'll be like, oh my God, this is going to save me so much time. Okay. All right. Well, that's it for the year. We're all done. Before we come back, we're in February. The Power BI Summit will be in February as well. So that's the global online Power BI Summit. Sam and I are doing a session on Power BI Data Ops with John Kursky, who's the Data Ops guy. We've got a live table talk session. I'm also doing a session on real-time data and KQL in Fabric. So go to that. That'll have everybody who's anybody in the Power BI world will be speaking at that at that conference. So look out for that. That's Rez's conference. You'll start to see that coming out. Well, they've just announced the sessions today, so expect to see that over the holiday period. So have a great, happy holidays. Be safe. Hopefully we'll see you all on the other side of the new year for another exciting edition of the Power BI/Fabric meetup. We've got one more session for the year, which is the Friday lunch and learn. I'll be doing, I don't even know what I'm doing. I'm probably just going to give away prizes and talk about something. Who knows? We're currently building a data platform. It's kind of fun. Join us on Friday if you can at lunchtime. Otherwise, we'll see you next year. Thanks very much. Thank you, Sam, for your work. Give Sam a round of applause, everybody. Recording will go up on YouTube. We'll put a link in the chat for those of you that are on the chat. Otherwise, if you look at our Shelley, pop the YouTube channel in the chat, and we'll do that. If you can put like the surprised emoji on this one, Thea, that would be good. All right. Or maybe the mind blown emoji. Yeah, okay. We'll work it out. All right, great session. Thanks all. We'll see you next time. Thanks, Sam.
Yep. No worries. Thanks, guys.